Hello everyone, my name is Atanu Mukherjee, and today I'm going to uh, present impacts of farming systems on soil health and water quality. So I am representing Rodale Institute today. So first, I would like to give you some instructions. So if you cannot hear any sound, then please let me know. There is a chat function here. You can see it. Um, if not audible, click audio settings left of your screen, um, and you can use the chat function or question and answer uh, dialog box in order to ask me any questions. I will respond to your questions or any queries or any discussion at the end of the presentation. For any technical problems, please call Maria Pop. She is our Rodale Institute's education coordinator. Her number is 610-683-1481. All right, so today I'm going to talk about impacts of farming systems, different farming management practices on soil health and water quality. This is a 6-year funded project that started last year in 2018. The funding agency is William Penn Foundation. And the total grant uh, given is $6 million that would be spread throughout 6 years. So in this project, we are going to collaborate with, like I said, collaborate with what Stroud Water Research Center, and we are using farming system trial, or in short FST, at Rodale Institute, and we are going to call watershed impact trial what we are going to establish, or we already established at Stroud Preserve. So the main objective is to conduct nationally significant research in collaboration with Stroud Water Research Center using applied research. Uh, our main goals are reducing pollution from agriculture, that is the water quality, improvement of soil health, and of course the end goal would be the crop yield, and we are also educating farmers. So the big issue is agricultural runoff. So a lot of pesticides and herbicides are being leached down or being surface runoff, and polluting the surface water as well as groundwater. So we are interested to see whether or not different management practices side by side can affect water quality, and as well as whether or not different management practices can affect soil health over time. So at Rodale Institute, we have a farming systems trial. In short, we call it FST, and that is the longest running trial system, farming trial system uh, in the world. It has been running since 1981, and it was designed initially by Bob Rodale in 1981 to assist farmers who were interested to transition from conventional to organic. And normally we use the grain-based systems, uh, corn and soybean. There are some others like wheat and oat. Those systems are being tested as well at the same time. So we are testing organic farming system versus conventional farming system side by side at Rodale Institute. So this is one component we are actually comparing when we are collaborating with Stroud Water Research Center for this William Penn project. So in short, at FST, we have three different systems established. One is organic manure, that is actually composted manure systems. And that in that system, we normally use long rotations of annual grains as well as the perennial forage crops. And we periodically apply composted manure. In organic legume system, on the other hand, we only use different types of leguminous cover crops. So we have like mid-length rotation of annual grain and cover crops. So in those two systems, both systems are actually organic systems, because we do not use any agrochemicals, any synthetic agrochemicals in these two systems. So so the nitrogen fertilization, we rely on organic legumes plants to produce nitrogen in the system. So we do not add any fertilizer in both systems. However, in the conventional system, we use synthetic nitrogen fertilizer and herbicides. And this is the system that most growers are using at this time. Now at Stroud Water Research Center or Stroud Preserve, we have 4 different system types we established: conventionally tilled, conservation no-till, organic till, and organic no-till. So here in the right side of your screen, you see that this side is conventional versus this side is organic, and these 4 boxes of each system, those are representing 4 replications. And this, we established these plots last year, 2018, and we are actually at this time we are collecting soil samples and water samples, as well as crop biomass samples over time. So this is the one component of our whole William Penn project, and we call it watershed impact trial. This one. The other one is FST, farming systems trial. So out of 8 different systems we have at Rodale Institute farming system trial, we matched 4 of them in order to compare side by side at Stroud Preserve. So we have like conventionally tilled, that doesn't have any cover crop, and conservation no-till that has cover crops, and organic, 2 systems organic, one would have cover crop and another only organic matter additions. That means the composted manure. Now, the Rodale Institute's farming system trial, as we are actually doing research on both systems, this one actually is in Berks County in Pennsylvania, FST, and as you see, there are like different soil types, 3 different soil types, and this is the whole area is FST, farming system, and the different systems and plots are actually are adjacent here. On the right screen, you see that we also have 2 different soil types as well. However, both soil types actually are both places soil types are actually silt loam. So the main soil texture is silty loam soil texture. The only difference we have here is that that FST site has 0 to 3% slope, versus the Stroud site that is much slopier. It's 8 to 15% slope. So we are actually seeing a little contrast here. The Chester County, where we established recently this watershed impact trial, that is actually a slopy area, versus the Berks County, where we have the FST, we have like a flat, mostly like flat ground. But overall, all those different soil types, as you see, these are actually fall into similar soil textural class, that is silt loam. We are looking at a number of different research areas. So here we are looking at obviously soil health and water quality, but we are also at this time are interested to look at nutrient density of different crops. And also we are doing a systematic energy analysis and economics. So how much energy is being input and how much output. Also like the revenue, how much revenue and how much expenses we are having under different systems. So these all are all under different types of research areas at this time. Here on the right screen, you see this is our farming system trials director, FST director, Dr. Emmanuel Omandi. And here are some other past researchers who worked here at Rodale Institute um, uh, at FST at various times. So the different soil health parameters we are actually looking at are physical, chemical, and biological. The physical parameters we are looking at are bulk density, soil compaction, and that soil compaction using penetrometer, aggregate stability, and as well as soil infiltration rate. Soil chemical, we are looking at pH or soil chemistry, different macro and micronutrients, total carbon and nitrogen, as well as cation exchange capacity of soil. And soil biological part, we are looking at organic matter of the soil. This list is not exhaustive list, but this is like most ones what we are actually currently looking at from the collected soils, first year of collected soils. So samples were collected from 0 to 10, 10 to 20, 20 to 30, 30 to 60, and up to 60 to 100 centimeter depth using mechanical soil coding probe. And the bulk density was actually determined using that probe. Aggregate stability of the total aggregate soils, and that was done using aggregate stability apparatus in the lab, pH and electrical conductivity by pH meter. Compaction, like I said, we are using field penetrometer, and I will talk about that a little bit later. The nutrients, cation exchange capacity, and organic matter, for those analysis, we send the samples to all the soil samples to different university labs. So normally we use either to Cornell University Analytical Lab or PSU, Pennsylvania State University's Extension Analytical Lab. Now, these are the water quality parameters. These are being done at our partner side. So the Stroud Water Research Center, their scientists are actually analyzing these. So they are analyzing the water, collected water for different agrochemicals like pesticides, dissolved organic carbon, suspended solids, different nutrients, mostly nitrate, nitrogen, phosphate, phosphorus, and ammonium, different anions as well. And indicator bacteria in the water, mostly coliform and E. coli. So these things are being done at Stroud Water Research Center by their scientists. So the way to collect the water quality was to use a lysimeter. So we installed lysimeters. At Rodale Institute, the lysimeters were already installed, but at Stroud Preserve, we installed those, and over time to time, we collect the soil water, and those collected water, those are called leachates. And those leachate volumes, how much from different plots or different systems are being collected, those are being recorded, just so that we know that how much water is being leached down. We also are using infiltration method to understand infiltration rate on the topsoil. So we used double ring infiltration method. Now also for the water samples, we in order to determine different anions and agrochemicals, nutrients, and different bacteria, they are sending the samples to different labs for analysis. So here we are looking at deep soil coding at Rodale Institute. So we collected soils, like I said, from 0 to 10, the surface soil, to all the way to 100 centimeter depth by using soil core probing method. And 5 random soil samples were collected from each plot, from both from FST and Shroud Preserve. So when you collect the 5 cores, the one core, full entire core, was preserved for determining bulk density of the soil, and the other 4 soil cores, those were cut by depth, like 0 to 10, 10 to 20, 20 to 30, 30 to 60, and 60 to 100 centimeter. And then they were actually aggregated. All the rest 4 cores were aggregated by depth. And those aggregated soils were actually sent for different soil nutrient analysis. And we use those aggregated soils for lab analysis, like aggregate stability and other measurements. So the soil coding, this deep soil coding, we are actually, according to the protocol, we are actually doing it first year, and third year and sixth year of the project. But in between those years, like second year and fourth year, we are going to only collect the surface soils, because deep soil characteristics normally don't change very fast. So here we are looking at 2 side-by-side soil cores, and you see that the left side is collected from organic system, and the right side from the conventional system. And you see that the organic soil had like very deep organic matter content. It's the darkness is all the way up to like 20, compared to the conventional is like about 10. So this basically tells you that organic system in our systems at FST was very much enriched with organic matter compared to the conventional systems. So like I said, this project actually started like last year, 2018, and we collected the baseline samples, soil samples and water samples earlier this year, and also last year, later part of the last year. So we do not have a lot of data right now on soil health and water quality. But I do have some historical data collected from FST, Farming System Trial at Rodale Institute, and I'm going to show you those. And some of the data some of the soils we collected earlier this year, those data I will present whatever I have on different characteristics. But keeping it in mind that this project is spanning like 6 years, so we are going to offer this webinar every year. So you will have an updated version of this research next year around the same time. So here we are looking at, this is the FST farming system trial data on organic matter. So here we are looking at how soil organic matter actually changed over time, a long time scale, 1981 to up to like 2016. So it's like almost like about 35 years of data. And we did not plot all of them, but what we see here is that overall, on average, conventional system actually had much lower, significantly lower organic matter compared to the overall legume and manure system. So, and it looks like over time, organic system actually improved the soil organic matter by 17%. It increased it significantly by 17%. And as you know that higher the organic matter, better is the soil health for a number of different reasons. Here we are looking, so we have some collaboration with Ohio State University and University of Tennessee and some other institutes as well. So here we're looking at soil organic carbon under different depths, 0 to 10, 10 to 20, all the way to 60 to 100 centimeter. So the researchers collected soil samples from these depths, and this organic, when we are, the blue is organic, the flat blue, and the shaded ones are the tillage. So this is the no-till and this is till. Then again, the flat one would be unshaded one would be no-till, and the shaded one would be tillage. So what we found that up to 30 centimeter soil organic carbon actually increased by organic system compared to the conventional system, and this increment was actually statistically significant under organic system. So this also, but after 30 centimeter there is no significant changes, and that is very common because the management systems, no matter how you manage your field, management system doesn't affect lower than 30 centimeter depth of the soil. So, but the take-home message from here is that soil organic carbon actually increased all the way, all different layers, all the way to up to 30 centimeter. And that was increased by organic system compared to the conventional system. Now, like I said, we have collaboration with University of Tennessee, and they also collected soil samples from FST, farming system trial. And here we're looking at how microbial biomass carbon that was affected by different systems. And a microbial biomass carbon is actually a measure of carbon contained in the living organisms in the soil. So basically, this is actually a fraction of your total soil organic carbon. So so normally, typically in the agricultural field, we see like if you have soil organic carbon up like say 50 grams per kilogram. Normally, the microbial biomass carbon, which is actually a measure of carbon content in the living organism like bacteria or fungi, that is about like 1 to 5% of your total soil organic carbon, and that is actually very relevant to the previous one. Here it is like up to 25 grams per kilogram, and here it is like about 70 milligram per kilogram. It's like about less than 5% of your soil organic carbon. So, and here we also see the similar trend that soil organic that organic manure and legume systems actually increased the microbial biomass carbon under 3 different depths. In the first depth, there was no significant differences as you see, but in the 10 to 20 centimeter depth and 20 to 30 centimeter depth, organic systems actually significantly increased microbial biomass carbon compared to conventional system. Here we are looking at soil bulk density, and the like from before, as if you notice that the blue is the manure, legume is the green, and conventional is the red. This is the color coding we have here. And you see that there is no significant differences under any depth. So if we just consider, like, let's say 0 to 10 centimeter depth, this is the 0 to 10 centimeter depth here for manure, for legume here, and for conventional here. We did not see any bulk density differences, and that is very consistent with the lower depth as well. However, the upper surface 0 to 10 centimeters soil's bulk density was significantly lower compared to the 60 to 100 centimeter layers bulk density, and that trend was similar for legume and conventional, and that is very common because if you go down to the soil, then your bulk density is supposed to actually increase. Now we collected soil samples for different other physiochemical parameters, but we also tested soil's compaction in situ in the field. So here USDA ERS scientists, they packed different soils in the container, and they grew different types of agricultural plants, and they found that root penetration, and they are trying to figure out how the penetration resistance of soil versus root penetration, and they found that root penetration actually decreased linearly with increase in penetration resistance. So here in the x-axis we have the penetration resistance of psi, that is pound per square inch. So if you increase the penetration resistance, the root penetration, they found that linearly decreased. But they found that after a certain point, and that point is 300 psi, after that 300 psi, no root can actually penetrate deeper. So and they tested on a number of different plants, and so this became the protocol that up to 300 psi, you would say that the layer of the soil is going to compact. So here is the penetrometer, field penetrometer. You push it down, and as soon as you reach 300 psi, then you stop there and get the length of the soil layer. So, and that is your compaction layer. And compared to that, here we are in situ critical compaction depth of different systems. And you see that manure and legume system actually the critical compaction depth is much lower compared to the conventional. So so in other words, the conventional plots are very highly and significantly compacted because the compaction layer is very shallow, like within 0 to like about 13 or 14 centimeter, compared to the manure and legume overall, like on average, like about 25 centimeter. So, and the take-home message from here is that our soils, the organic soils under the organic systems, those soils are actually much less compacted compared to the conventional soils. We also determined the infiltration rate in situ using the double ring infiltrometer technique under FST. And what we found here is actually also related to the compaction, because remember, the manure and legume organic system had much lower compaction compared to the conventional, and here it is actually reflecting that data, that infiltration rate actually increased significantly under organic systems compared to the conventional system. So infiltration rates actually increased all the way up to like 3.7, like almost like 4 times compared to the conventional systems here. We do not have the same 2019 data. The other two slides you had 2019 data, but this is 2017 data on organic matter. But here from this data, we are seeing that at this point, in 2017, at FST, the under both no tillage and tillage conditions, the manure and legume system, that means the organic system, actually had significantly higher organic matter percentage compared to the conventional. So the conventional plots, they have on average, say, about little less than 4%, like 3.9%. And here the organic and manure system on average has like about 4.4%. So that is about like 14% increase. So the reason behind the higher infiltration rate and higher and lower compaction under manures and organic system is because of this data, because of higher organic matter content under those two systems compared to conventional systems. So we also are are analyzing different other soil physiochemical parameters like total CNHO, pH, and nutrients, cationic capacity, aggregate stability. So here are different times we took photographs of our field activities and lab activities, and these are the researchers from both Stroud Water Research Center as well as at Rodale Institute. We installed Lysimeter at Rodale Institute in 1991, and then we have been collecting water, leached water over time. Like, so every year, like mostly like 2 to 3 times, we normally go out and collect the leached water, and these lysimeter experiments actually showed us particular graphics here from 1991 to all the way up to end of 2002. And those leached waters were analyzed for nitrate, nitrogen, and we see that mostly conventional system actually had initially very high accumulated nitrate, nitrogen. However, at this point, around end of 1995, legume system actually leached more nitrate, nitrogen compared to the manure system. So what happened here was in around 1995 was a drought year. So there was almost no rainfall in 1995, but in 1996, like very early 1996, and so this is the jump here, and the late 1995, like around the fall 1995, and late fall of 1995 and early 1996, we had a total rainfall of 1650 millimeter when the average yearly rainfall is 1100 millimeter. So that actually accelerated the nitrate, nitrogen leaching from the legume system. We also noticed that normally the hairy veg, the production of nitrate, nitrogen from the hairy veg, that actually got almost doubled under the legume system. And because 1995 was a drought year, the crop yield was not that good, and so the crops actually couldn't take up all the nitrate, nitrogen around this time. So, and then we had like similar weather variability over time. But keep in mind that like after 2002, there's no significant differences between all these three systems. So eventually, we although we saw that conventional system was higher in nitrogen leaching compared to manure, but it was lower than legume. But all these three systems, when we ran the statistics, there was no significant differences. But keep it in mind that these data are from 1991 to 2003, and we will have more data analyzed like from 2004 to 2019. So the last 15 years data, we are going to analyze those data, and these dynamics might change over like past 15 years of time. Now here, like I said, we had a 1995 drought year, and we had very low rainfall. The rainfall was only 13 inches, when the normal rainfall is about 43 inches. So, and here we see a side-by-side organic versus conventional, and you would see that corn yield was higher by 31% under organic compared to the conventional system. We are not showing the soybean photograph here, but soybean is got higher all the way by double, like 200% under the organic system. So the agro-system resilience is another good thing about the organic systems, because it, as you can remember that in the first slide I showed you that organic matter actually increased significantly under the organic systems, and that actually holds a lot of nutrients, and the built up organic matter actually supplies all the nutrients that is needed for the crop to sustain it. So basically during any stress condition, we normally see that organic system fares much better than the conventional systems. So here a typical corn yield presentation here. So as you see that this is the first one toward the no-till and till conventional, the second toward no-till and till organic legume, and the third is no-till and till organic manure, the composted system. Now the first and second, they are not significantly different in terms of corn yield. The county average was 154. Compared to that, in that particular year, we had like organic no-till, organic manual no-till has like all the way like 200 bushel per acre. So that was very significantly higher compared to the other systems. But let's talk about the first two. So this is the conventional and this is the organic, right? So although these two systems had no significant differences in corn yield, however, the potential revenue from the organic legume corn was almost like 3 times higher compared to the conventional corn. So the reason behind it is that you are getting a premium price for growing crops organically. So the organic farmers normally get a very high price compared to the conventional system. So although in these two systems, legume and conventional systems, the overall average corn yield is like about 145, 150. The organic farmer is going to get much higher price compared to the conventional farmer. So the summary here is that some of the soil physicochemical parameters were significantly changed, and there is no change on some of those parameters. For an example, the organic matter, historical organic matter, the pattern showed us that both organic systems, manure and legume systems, had significantly high organic matter content, and the conventional system almost stayed flat over time. Soil organic carbon under different soil layers, those are actually significantly increased by organic systems, while the actually soil organic carbon under the conventional system actually decreased. Soil biomass carbon actually significantly increased again under the organic system compared to the conventional system, it's actually decreased. So these three actually very good for build up soil health. Soil bulk density, we anticipated that the soil bulk density would actually reduce, would decrease under organic systems compared to the conventional systems, but we did not see any changes, at least not in the first phase of the research. Soil compaction, the pentameter resistance, we saw that the organic system actually significantly decreased the soil compaction. But the conventional system actually increased it. Infiltration rate increased by organic system, but the conventional system actually decreased that. Nitrate leaching, we saw that legume system actually had little overall a little more increase in nitrogen in the leachate compared to conventional, but there was no significant changes under both conditions. So these are all my data I have at this time. So I would like to stop here and would like to welcome any questions if you have at this time. You can write the questions either in the question and answer dialog box, or you can use the chat function and you can send me your questions, and I will read it and I will uh, try to explain or have a discussion on those. However, some of the questions I might not have answered this time, and I would like you to send me an email, and I will get back to you with the response. So here, let me look at the questions we have here. Okay, so the first question here is what happened in 2006? It looks like all saw a decrease of organic matter. Okay, that is also so here is the okay. Um, so they say so here we are seeing there is a decrease into 2006, and this is the question I also have, and I do not currently have any response to this particular year around 2006. It looks like all of these systems, manure has like uh, a big jump, and legume as well as, but and conventional also had a jump here. So uh, we see a decrease in organic matter in this 2004 2006. So in within these 2 years, I do not currently have all of the data at this time, and I will have to go back and check what happened in 2006, why those systems actually decrease the organic matter. But overall, if you ignore this part, then you would see that overall it's actually uh, the dynamics is actually increasing trend, if you look at the average manure and legume systems. That was by Jennifer Dowdell. Let me write it down. Um, so another question is from Andy, and he's asking, is the organic manure sole sourced from a specific species, or is it a mixture of multiple? It's a mixture of different types of species, not from only one source. Okay, so there is another question by Tom, and he's asking, would you recommend to people wanting to start organic agriculture business to also have a source of manure, doing a sort of diversified production like animal farming and agriculture? Would you also recommend a sort of integrating animals and crop systems? We always recommend integrating animals and crop systems. The reason behind it is that then you will have a source of nutrients when you integrate animals, and we call it regenerative organic systems. So yeah, it is best if you can integrate either dairy or poultry farms in your grain cropping system. That is very much recommended by our protocol. Yeah, so the source of manure is very important. You don't have to, so one analysis we are doing is to figure out whether or not it is more expensive under different systems. And the data I have at this time, it shows that after like few like about like 5 or 6 years of uh, revenue analysis, it looks like conventional total expenses was like $810 per hectare per year, versus manure was 788 per hectare per year, and legume was only 534 per hectare per year. So that these data actually indicate that if you have the manure system integrated with your grain cropping system, that would be even more advantageous. Then you don't even need to have another nutrient source to fertilize your soil. Is there any data? So One question by Avery Nicastro Aikman, and Avery is asking, is there any data on the input or labor costs on the three different systems? Yes, we do have some data, systematic data analysis, like I said, and I do not currently have all of those, but uh, I think the energy, as far as the energy is considered, we saw that no-till legume was the least energy intensive, followed by tilled manure, followed by tilled legume, followed by tilled conventional, and followed by no-till conventional. So the conventional system looks like more energy intensive compared to legume and manure system. So legume system was like, so far as what we saw from our data is that legume system was like um, least labor intensive. One question here is by Lucy Kane, and Lucy is asking, does the Rodale Institute have any long-term research regarding agroforestry systems, or even comparing regenerative versus organic versus conventional? So we just started the regenerative versus organic versus conventional, and for the regenerative soil sampling protocol, we just developed it and we are working on that area. So, and eventually we will end up with a system approach research on that. We have the long-term research on grain cropping systems, and we also have fairly moderately timescale research on vegetable systems. As far as the agroforestry systems, uh, as per my understanding goes, we do not have it at this time, but I will get back to you on that note on at a later time. Um, One questions my Hamish, and Hamish is asking, are you going to include livestock in any trials? These watershed impact trial and farming system trial, those are already established. Farming system trial was established, like I said, about 40 years ago, and we are not including particular livestock in the trial, but we are using the only using the manure. For the watershed impact trial at Stroud Preserve, we already have some protocol established, so we are not going to add any other component in the trial except what I already discussed. Okay, so Jennifer, you said thank you for the questions. Thanks all for the questions. That's these are the only questions I am seeing at this time. So again, if you guys have any more question on any of this, please let me know. Let me quickly check if there is any question from chat function. Okay, so I do not see any question from the chat function. So I assume that these are the all questions I have at this time. And again, thank you very much for joining me for today's webinar. And please let me know if you have any question, and I'll get back to you with my response. Thank you so much.